Hi, welcome guys in a new episode from the Vigilante, mamon rasool. And I'm here today about talking about the big data concepts. In the first video, this is just to be an overview about what is big data and why we need Hadoop to process this big data, and what is the replacement for big data in the cloud. And we are going to use AWS, Amazon Web Service, if we need to go to cloud. So the first thing that we need to learn is about Hadoop and Hadoop ecosystem, but the zero step or the zero stage, we need to know what is this big data. Well, maybe many ask about can we consider a huge amount of data as a big data, or how I know my data is a big data. Why you need to know? Why you need to know that your situation is a big data or not? Because if you're going to use a solution that's meant to work in big data, and you are not in big data case, you will going to end with a bad experience with Hadoop, maybe, and maybe the solution that fits you is not a big data solution. So you must understand your situation than to choose upon your situation. So before we talk about Hadoop and how Hadoop solve a problem, let's understand big data. So big data, some call it the big 3V, and I like IBM said it is the 4 big V. What is this V's, big V's? Big V's, the 4 big V, it is about 4 word that begin with the V, the letter V. The first thing is we call it the volume. Of course, if it is a big volume data, let's say you have a terabyte, 100 terabyte or petabyte, it is a data that cannot be fit in one PC. Maybe sometimes the data itself, it can be fit in one PC as a storage, but it can't fit to be processed in one PC. So let's say you have a text file with a 1 terabyte. This text file can be stored in a normal hard disk with a 2 terabyte or even 4 terabyte, but you cannot open this text file with the one PC, no matter what it's this PC, even if it is 4 CPU and 64 core or something like this. This is very big file, can't be opened by program itself, so we need here a parallel processing to process it. Now the another V, we call it the velocity. What is the velocity? Let's say you are working in application that generate a data, let's say you are working on application that take a Twitter data, and you are featuring about 1 million tweets each minute or each second, and or something like this. It can't be processed in one PC, it can't be go in network for one PC. This will make what we call it a bottleneck. What is bottleneck? If you send in this amount of data to one node, there will be about a network bottleneck in this node. So here you need a distributed node that each can take a specific amount of data. Now there is the another V, and it's named the variety. It means that your data is a schema disk. Anyone working with the NoSQL database know what is a schema list. If you have working with MongoDB is a schema disk database, so there is no schema predefined schema for it, and so the variety is about as we said, it is a schemaless database. A schemaless data, sorry. A schemaless, maybe you have a file that's CSV, others is log, the another one is images, the another one is videos and MP3s, and there is many different types, and you don't know which data type you will receive. You don't have a schema for your data, so this is also has to fit in your solution. The RLV that is added by IBM, it's the uncertainty of the data. It mean versity. It mean versity means uncertainty of data. So maybe you need to store about 2 terabyte data per second, but these 2 terabytes, maybe it have 1 gigabyte is what you need in your statical, in your freeze, and is the real data is 1 gigabyte, but you can't share this 1 gigabyte. You have to store the others, so you have to store all the incoming, all the input, and then try to process it. So that's what we have in here. This the 4 V's will going to lead you to choose this type of solution or not. So don't blame the solution if you choose it for another big data problem. I'm going now to talk about Hadoop and why Hadoop is here. If you can see this window, it is Ampari server, and this Ampari server has installed HDFS. It is Hadoop distributed file system with a MapReduce, Yarn, Pez, Hive, HBase, and other services. It is what we call it Hadoop ecosystem. So let's talk about Hadoop. Well, you see that this 4V is a really big problem, and I search in Google just to take the IBM infograph. It is something nice that you can understand my what I have described earlier. So let's see it. So if you see, this is a real problem. So Hadoop came as a framework, a distributed framework that solve all these problem. So how Hadoop solving this problem? The first thing, Hadoop, let's see the infograph. As you can see, huge amount of data. The internet is so bad, so let's talk about Hadoop. So the first thing Hadoop came with is it's a distributed file system. Maybe someone asked, we have many solutions for distributed file system. We have many software-defined file system. We have GlisterFS, GridFS, and also Ceph and Swift, many types of distributed file system. Yes, it is. There is a many distributed file system. But it can be. The first thing, distributed file system is key to solve the first area. It is the volume. So you don't have to store the data into one big node. Each file came to Hadoop will firstly go to something we call it a main node. So what is main node? Main node is something that store the metadata of data. It have a configuration that this configuration is about a block size, and what is a block size? A block size is that each file will be going into multi-part, let's say multi-chunk. So if you have 1 gigabyte and this gigabyte and your chunk is 100 mega, it is or 128 mega per chunk. This your file will go about 9 block. So this block, this file will be in multi-block and stored into HDFS. Now the HDFS will store the meta, the information about each block where it is stored into main node, and then will store each block inside data node. And there is also what we call it a replica factor. So the replica factor, or the replication factor, is about to make something like a backup for each block inside a different node and maybe in different rack, because Hadoop is a rack awareness. You can define also the rack, so you can have a really good backup option for data. So this is the first thing, is about the volume. Now what about variety? Okay, Hadoop, it's not asking you what type of file you're storing in, and you can store any file. Then this file will be processed by you into many different ways, and you can also set your, sometimes you call it file types you need to work in with. There is a sequential file, there is a text file, there is also you can connect it with another solution like SQL, and make it, store it in some type of database that is with the Hadoop ecosystem, like Hive, something like this. So the other thing also is when we talk about volume, we said not about the file can't be fit into storage in one PC, but is also about processing this file. So what Hadoop do here? If you see in here, there is a MapReduce and RAM. Another thing, there is a POS. Let's talk about these two before we talk about this. So MapReduce, it's the idea of MapReduce is that there is something we call it data localization. There is a theory in Hadoop said that your code cannot be bigger than data in any manner. So the data is always bigger than your code. So what I will do for you here, I will send your code to the data. So what is here is that when you're executing the job, that there is a small portion of data or some function that we call it a map. This map will go into each block in each node and each data node, and process what's inside this block. Let's say you have a billion record into a CSV file, and this has been chunked into about 1000 chunk, and so each map will go to, and you have about 100 data node, so each map will go to one node, and maybe it will go to one node to read one block as you define it, line by line, word by word, as you define it in your function in your programming. So when this map has completed the result, it's and the another map, and there is multiple maps, it will send the data to sometimes another layer we call the shuffle, and then the data will go to multiple reducer. Reducer will take the result of the mapper. So then the reducer will have then the reducer will came with the last result, and that you have either to write it into HDFS, write the result, or output the result. So if you see here that we using parallel processing to solve the problem, the code go to the node and process and get back to us. So I will tell you about YARN and MapReduce, because YARN, it's as they call it, yet another resource manager system. So YARN, it's actually about to managing this resource and giving what we call a container for each process and something like this. We will talk about this in technical, but I'm here about an overview, so it make you to know what is happening. So as you can see in this principle, there is no a problem with the data in network, because there is 1,000 node, and simply each node will going to get its network link and will take the data. We can store as many files as we need, and we can process as we need. There is another thing that you need to put in mind. Hadoop itself is a batch processing system. What batch processing system is mean you have to process data in batch. So you choose a certain amount of time to run a task, then get the result and save it. There is another solution to work around this and working in real time using Kafka and Flume and some so you know we have a log file need to be processed in real time. You can install Kafka and send the data from Flume to Kafka. Kafka is about if you are a computer science graduated, you know what is a query. Kafka is a query, messaging query. So Kafka will handle the process into messaging query and work around the real time. So you can connect Kafka with the HBase or with the Spark and working around real time streaming. It means that the data is processed in real time. This is another thing, and I hope I have time to complete all the services of Hadoop ecosystem and describe them one by one. This dashboard, as I tell you, is Amparo, and it is not mandatory. There is a multiple version of Hadoop. Hadoop, the one that is open source, it's from Whole to Network, and it came with Ambari to manage Hadoop ecosystem. And there is another distribution is the Cloudera. There is MapR. Also there is something. There is another solutions, and there is a cloud solution that contain Hadoop as a service. I will work with AWS. It's not because I am a certified solution architect from AWS, but if you work with AWS and if you combine AWS with others, you will find that you are working with a different and very big and very organized cloud, and there is a solution that provided by AWS that not provided by others cloud provider. It's not my opinion. All in our community said that, and all statics said that AWS, Amazon Web Service, is the leader of the cloud from about 2030 or something like this. So it is a different topic. I will talk about AWS. I just want to mention it that we want to make episode for cloud computing and big data processing and Hadoop, because all this episode will be uploaded into my group. It's called Iraq Big Data and the Cloud Computing, and I hope to accomplish this thing in the nearest time, because I have really many jobs to do and many tasks to accomplish, and I want to prepare to master degree. So this is what just an overview about what you will learn in this episode and what we are going to do. Actually, I don't have something in order to talk just in this. I just want to be brief. So thank you for watching. Was with you the Vigilante and Mamon Rasool.